complementary events. So if two events are complementary, they must both cover all possibilities. So what's the complementary event to it raining? Is it sunny? Is it windy? Well, no, the complementary event is it not raining, because that covers all other possibilities. What's the complementary event to coming first in a race? Is it coming last? Is it coming second? No, it's not coming first. So it covers all other possibilities. If this is the case, when you go to add these probabilities together, they should equal 1 because they cover all possibilities. And we can write this a little more generic, saying if we have a probability of some event, the complementary we write with a bar on top. So that's the complementary of that event, and that equals 1. We can do a bit of algebra to rearrange this by saying the probability of some event is 1 minus its complement. So just by subtracting this term on both sides, we'll end up with this. And this can be very useful when finding probabilities, when sometimes it's easier to find the complementary of an event rather than the event itself. And usually when the words at least are used is when it's going to come in most handy. So let's have a look at an example. Let's look at 2 coins being tossed. And let's draw the tree diagram. So you can get a head or a tail on the first one. If we get the head first, we can still get a head or a tail on the next one. If it was a tail first, we could still get a head or a tail on that one. Each of these probabilities is a half. Now, what's the probability of getting at least one head? Now, we've already spoken about when this word at least is used, it can be very handy to find the... Let's think about what it means, at least one head. That means we could get 1 head or 2 heads. What's the complement to getting at least 1 head? So we can get 1 or 2 heads. The complement to this is actually getting no heads. So we could rewrite this probability as 1 minus its complement. So 1 minus the complement is getting no heads. And what's another way of writing no heads? Well, that would be getting 2 tails. So now we can find the probability of getting at least 1 head is 1 minus the probability of getting 2 tails. The probability of getting 2 tails is just here. So we can just do a half times a half for the probability of 2 tails. That's a half times a half, where we get 1 minus half times a half gives us a quarter, and 1 minus a quarter is 3/4. So the probability of getting at least 1 head is 3/4. We didn't have to use complementary events. We could have found the probability of getting at least 1 head, which is here, here, and here, and added them all together, and it still would have gave us 3/4, but this is a bit of a shortcut.